All right, here is a video for 10.3 and 10.4 practice A. Little two-way tables here, little probability tables, just kind of give you to see how kind of chance things have. So let's take a look at number one. It's about running a half marathon. And so how many have you run a half marathon? Yes or no? So if they've given you one part of it, you can actually fill in the other part. So if they said 12 people yes, that means that you've got 112 people that are no's, because it has to add up to 124 total. So you just subtract 124 minus 12. And then you've got, out of those no's, how many are teachers? So you can take 263 and subtract the 112. You get 151 that were teachers that said no. Now you know how many total teachers there were. There were 158, because you can add these two together to get 158. Let's see, how many yeses? There were only 19 total yeses, 12 and 7. And then if you look at the two totals for all the people, you have 124 plus 158. You get 12, when you get 8, so you get 282. And that should be what you get if you added those two together. 19 and 63 does give you 282. So now you could make probabilities, because now you know your total number is 282. So you could make probabilities out of that, and with your part out of your whole, and it'll make it easier. The second one, we're talking about dog owners and cat owners. Again, you could fill in the different pieces. If they've given you how many people own a cat that also own a dog or do not own a dog. So you've got 24 people that own a cat and a dog. You got 61 people that own a cat but not a dog. So we were talking about 85 cat owners. 85 cat owners. And then we've got 107 people that don't own a cat that do have a dog. We would have to go to the total for column next, because we could take the 226 and we could subtract the 85 from it. That's 1, and that's carry there. You're going to get a 4 and 141. 141 people do not own a cat. So if we take that 141 and subtract 107 from it, you'll get a 34 people that do not own a cat or a dog. So 34. They own nothing. They don't own any animals. So how many people do own a dog? That would be 131 when you add these two together. And then how many people do not own a dog? That would be 95 when you add those two together. And if you add those two together, that should give you your 226, which it does. Now, again, you can then get probabilities. You could say, how many people own a dog and a cat out of everybody surveyed, and you would say that would be 24 out of the 226, which would be a pretty small probability, 24 out of 226 that own a dog and a cat. So that's number 2. Number 3 is the last one, and we have the chart down here. So I kind of made the chart already, but let's read the problem. It says 112 people felt that the amount of fresh water allowed to empty into the salt water should be reduced. So 112 people thought that it should definitely be reduced. So yes, 112 would actually be a total number. We don't know how many fish or don't fish, but we do know that 112 people said yes. So the total yeses are 112. And it says 87 people did not feel that the amount of fresh water should be reduced. So we now know 87 goes down there at the bottom. So we now know that we have a total of 199 people, because if you add those two together, you get your 199. So we come back up there to the problem. It says, of those who feel that the fresh water should be reduced, 98 people fish. So out of the 112 yeses, 98 yeses do fish. The other ones don't. So the other ones that don't, then if you take 112 minus 98, you're going to get 14 people that want it to be reduced, but they don't fish. Okay, and that says of those people that feel like the amount of fresh water that do not feel it should be reduced, 12 people fish. So there's 12 people that don't want it to be reduced, but they do fish. We know there's 87 total, so 87 minus 12, you get 75. So now we can tell you that 110 people fish and 89 people don't fish. So if you wanted to get some probabilities or some percentages, you could put each of these numbers over 199 and get their probabilities. So I could put like 110 over 199. I could divide that on my calculator, and you could see, what kind of percentage that would be if you use Desmos scientific calculator. You could do 110 divided by 199, and you see it's about a 55% chance, 0.55. So you could say that's a 55% chance that the people fish. There's 55% of the people that fish. So there's going to be about 45% of the people that don't fish. And then you could do that percentage for each one. How many people that want it reduced do fish? So 98 over 199. You could find percentages for any of those. So that's just basically number 3. All right, 10.4. Let's check out 10.4. And we're kind of looking to see, what's the probability of one or another thing happening. So the key word here is or. Okay, that's our kind of our key term there is or. Oops, you need to see it. So there we go. So first probability is 0.4. Second probability is 0.2. So when you're doing an or probability, you are going to add. So 0.4 plus 0.2, you're going to get 0.6. Now, normally when they're disjointed, you're going to do probability of A plus the probability of B. But then you're going to subtract any overlap, which is like probability of A or B. So we'll look at a few of those for you in a minute, but let's look at number 2 is not going to have overlap, so it's just 1/3 plus 1/2. You've got to be able to add fractions, so you've got to get a common denominator. So we're going to multiply this fraction times 2. We're going to multiply this fraction times 3. And you'll see your answer there is 5/6. 5/6, because you've got a common denominator of a 6. Let's see. High school swim meet. You and your friend are competing in the 50 freestyle. You estimate there's a 40% chance you will win. There is a 35% chance your friend will win. What's the probability you or your friend? 40% plus 35%. There's no overlap. It would just be either you or your friend. So 75% chance that one of you would win. All right, let's look at 4. Now, here's where your or is going to matter. Your overlap might come in. What's the probability that you roll a 2 or an odd number? So the chance that you'll roll a 2, okay, the chance that you'll roll a 2 out of dice is 1/6. The chance that you roll an odd number, 1, 3, or 5, is 3 out of 6. 3 out of 6. So you get 1/6 chance to roll a 2, a 3/6 chance to roll an odd. 2 is not odd, so there's no overlapping there. So it's just 1/6 plus 3/6. And you're going to get 4/6, but you should reduce that to 2/3. So 2/3 chance that you could get a 2 or an odd, a 2/3 chance. But when you look at this number 5, what's the chance of you rolling an even number? There's 3 even numbers, 2, 4, and 6. Okay, so there's 3 even numbers. What's the chance that you roll a number greater than 3? That would be 4, 5, or 6. That's 3 of those as well. But 4 and 6 are also even. So 3/6 plus 3/6 minus the overlap of 2/6. Okay, so this little piece right here is an overlap, because 4 and 6 are also even. So they would actually fit into both categories. They would be an even category, and they would be greater than 3 category. So they would actually fit into both categories. So you got to, after you add the 2, you got to subtract those 2 out, because you can't get them twice there. So 3 plus 3 is 6, minus 2 is 4, 6, which again reduces to 2/3. Now let's see. You bring your cat to a veterinarian for a yearly checkup. The veterinarian tells you there's a 75% chance that your cat has a kidney disorder or is diabetic. 40% chance kidney, 50% chance diabetic. So 40% plus 50%. So it says, what's the chance that your cat has both kidney disorder and is diabetic? So 40 plus 50, and then the overlap is 75%. Because 75% is kidney or diabetic again. So basically you're looking at 90% minus 75%, which is 15% is the chance of that happening. So that goes to this problem here. Game show has 3 doors. A grand prize is behind one of the doors. A nice prize is behind one of the doors, and a dummy prize is behind one of the doors. You've been watching this show for a while, and the table gives you estimates of probabilities for given scenarios. Find the probability that you win either a grand prize or a nice prize if you choose door number 1, is the first question. So you've got the door number 1, grand prize and nice prize. If you add those 2, you get 0.65. Find the probability that you would win it if you have door number 2. 0.45 and 0.25 is 0.7. And door number 3 is 0.65 again. So which door would you choose? I would choose door number 2, because that's a higher probability. Greater probability. So you get a better chance if you pick door number 2. And that is 10-3 and 10-4.